Hey guys, welcome guys. Today in this video we are going to explore this what is I, okay? In the previous video I have given a rough idea of what is Euler's formula looks like and the incredible blending of trigonometric functions and the exponential function and which gives rise to the phasors. In this video we are going to look into what is the value, the I in terms of engineering concept, okay? So now we all know that we have that the complex number c can be written by x plus iy. Okay, so in the plane Cartesian coordinate we can say that this is a complex number z and it has coordinates x, y. Okay, and then if you just project here, so this is x and this is y. Okay, y. So now, if you want to find the hypotenuse of the triangle, you can say, you can draw a line here, and what is the length of this vector. So if you do this, what you will get is that, just to find the length of the vector by using Pythagorean theorem. So we have that, for example, if this is c bar, then we can say that our z bar is nothing but x squared plus y squared whole root, right? So this is Pythagorean theorem. Now if we have that this is c and if we have some angle here, angle theta, okay, saying that tangent theta equals to y by x and theta equals to tangent inverse of y by x. So this is the origin of the angle. So now if we want to express this x in terms of our vector z bar, z modulus of c and theta, what we can do is that we can take the cosine of this. If we take cosine theta, then we have that cosine is adjacent divided by hypotenuse, right? So we have x by z bar, which implies our x equals to z bar times cosine theta. So if you want to find y, we can take the sine of the angle. See here, sine theta equals to y by modulus of z, which is opposite over hypotenuse, and we get y equals to z bar sine theta, right? So now in Cartesian coordinate we can write like this, but in the polar form our this one will have just z bar and theta angle. So we can write this in terms of polar formula as what? In terms of polar formula we can write z equals to z bar cosine theta plus here I, what is y? Z bar sine theta, and z equals to z bar cosine theta plus I sine theta, right? And if you see very carefully, you can see that this is just the Euler's formula. So we can write like this, modulus of that e raised to I theta. So with this, we have proved that every complex number can be written in this form by using Euler's formula, okay? So this is very important here. So I can write like this for you. I can say modulus of z e raised to I theta, where modulus of z equals to x squared plus y squared whole root, and theta equals to tangent theta y by x, okay, for you. I hope you have understood this. Now what we will do is, we will try to express what actually is I, okay? So now, we have something like this. We have that I is negative square root of negative 1, right? So if you square this, then you will get negative 1. And if you take the triple power, which is IQ, then if you see this, you can write I times I squared equals to negative I. And if you do 4 times, then it is positive 1. Okay. So now, I can also write this z equals to x plus iy. So if you see this very carefully, by writing this is equivalently good as writing this, okay? Because all the information which has x square and y square is contained in this z modulus, and the angle contains the angle subtended from the origin if you are traveling clockwise. So this information is as good as this information. So we call this polar form and this as Cartesian form, or you can say rectangular form. Okay, so it's like that.